Call from Supermicro back at you, continuing with our podcast on managing Ampere servers through lifecycle management. In the previous video clip, we focused on PodView, the signature of SuperCloud Composer, a signature feature customers absolutely love in managing your software-defined data center for rack management. So before we get into the particulars of rack management, I want to identify a couple of use cases around that, right? You maybe perhaps are looking at rack management or providing some type of PDU management. We built in a universal agent to support all the server manufacturers of PDUs, Schneider, Legrand, Eaton, ServerTech, which was acquired by Legrand, and other various key PDU manufacturers that are providing power requirements for a rack. And we're going to add the PDU in regions within the rack, which are strategically located in the rack. I noticed here that I have spelt a couple of things here or really didn't accurately describe my rack management here properly. I see here that we have a typo. We didn't add in building 6. So I'm going to go back into PodView for this particular rack, and I'm going to change this to building 6, F1, floor 1. And then I'm going to also save it. And you can see here by going into the edit function here, you can make changes to the various fields within the rack of the rack information. So in this case, also when you define or create or configure a PDU, it has to be an intelligent PDU, something that can be managed and monitored. Anything that is unmanaged from a PDU, we're not going to be able to provide crucial sensor data or being able to manipulate or shut down the outlet itself, right? So in our data center here, we have a unintelligent PDU that's in rack location of F2 or floor 2 of our rack that's not managed and providing sensor data. And then we also have in the floor 1 a intelligent PDU that is able to provide sensor data and be able to control the PDU. So let's add that in. And so we come down here into the PDU information and we click on the add function, and it opens up a new template or screen that we can add in specifics about the PDU. So the first thing is the location. So we have 4 regions or 4 sections within the rack that you can define. Perhaps you might have different vendors within that rack that provide PDU management, or you maybe want to standardize on one vendor, such as Schneider Electric or Legrand or Eaton. So we're going to plug in location A, which is the section or region of the rack, which is we've added and mounted within our rack. And you can see here we have various manufacturers that support basically PDU management. So Raritan is part of Legrand. We have Schneider Electric. ServerTech was an older company that was acquired by Legrand. There's still quite a few out there that provide, it's a pretty popular PDU that provides managed intelligent PDU sensor data collection and PDU outlet of controlling, whether you want to cycle the PDU or you want to shut it down or you want to start it back up again or provide power. And then we have the SKUs, right? So we want to choose, in this case, Schneider Electric. We have these various SKUs that have been validated under SuperCloud Composer. So the one we have in our data center is the AP 8641 type of PDU. And then we're going to plug in the IP address, 172.24.199.19. And then we're using the default community string, S&P community string as public for both read and write. You probably want to use a community string that is not default public, because that could open up a security vulnerability there. Maybe you have a specific community string that you're utilizing within your data center. For our simple purposes, we're just using public, and then we're going to plug in the right community as public as well, and then save it. And then it'll go out and perform an API call to the PDU controller. And then we had success here in our Redfish call to the PDU. And then you can see here that now we have a PDU that is associated with this rack. And so this rack is being controlled now by PDU management. And the icon to indicate the electrical socket indicates a PDU has been associated with this rack. And if you come up here and hover over through the tooltip, you'll see the IP address and the SKU name associated with that particular rack. Now, you can also come down to the PDU console here, and you can also see here that eventually when we gather the appropriate metadata, you'll see specifically this particular PDU show up in the list, and we'll be able to look at sensor data and things of that nature. So we'll come back to that a little bit later in the presentation once it gathers all the information and then populates it to the front end through our WebSocket. So I want to go back to PodView, which is our signature feature within SuperCloud Composer, and focus now on the Ampere farm. Notice here we have 2 racks, and now we have a socket, electrical socket associated with building 6, floor number 1. So what do we do next, right? We've created the 2 racks. We've associated those 2 racks to a pod. We've called it Ampere Farm. You can look here on the left-hand side through our tree architecture to show you that these 2 racks are associated with the Ampere Farm. And by looking at each one of these individually, you can break out and look at additional information. You can see here PDU information is associated with this building 6, floor number 1 rack. And then if we look at building 6, floor 2, no PDUs are associated with, because we don't have an intelligent PDU that is basically monitoring and managing this rack. It's just providing power for our use case here. So that's a little bit about our signature feature within PodView, and what we provide is logically representing various software-defined data center rack management within our data center. So what do we do next? We now take these servers and associate them with racks. And so how do we do that? Well, we come over to the edit mode here again option. And as I mentioned in previous videos, we have the option to do what we call device discovery. And so we're going to start performing device discovery of these Ampere servers that exist and that are connected through our management switch, our network management switch that you have within any environment. So you have the BMC that physically connects to these network switches and provides lifecycle management so that we get access, that we can perform our Redfish endpoints to the source of truth being the BMC, open BMC of that Ampere server. So we're going to perform our device discovery. So our device discovery can be done through 2 mechanisms, through an IP range. Remember I talked about earlier about having contiguous IP address space within to perform your device discovery. So you can do a ping spray starting with your beginning range and your ending range. In our case, we don't have contiguous space, so we have 4 Ampere servers that we're going to do device discovery on. 3 are 2Us, and 1 that is 1U. And we're going to associate each one of those Ampere servers to a specific rack. The second way we perform this is through SSDP. So you have the option to either do a ping spray to manage and device discover these through device discovery through a ping spray, and the other way is through SSDP, which is the universal plug and play that we have defined within our BMCs by default. And all of our BMCs through Supermicro have SSDP enabled on the BMC. If you don't want to perform SSDP, you just simply go to that BMC and turn it off. There's a capability and functionality within the BMC that you can turn that off and disable it. But by default, they're all enabled. So the first thing we're going to do is take the first T2U Ampere server, and which is the form factor, and do or perform a device discovery. So let me get my notes here. So all of the servers today are Ultra Max processors. So those are typically R12 type servers. We'll show you next time R13, which is a next generation of Ampere servers. But for this particular use case today, we're going to focus on associating R12 or Ultra Max processors with each of our racks and associate them with a group or a Ampere farm pod. So the first one we're going to do is the ARS-210ME-FNR. It's a 2U type of Ampere server. We're going to plug in the address 172.24.199.39, and we're going to use the N range of 39. So we're doing a single discovery of 1 Ampere server. We're going to click the submit button here, and it's going to start defining or pushing a task to the back end. And you can see here that the cloud icon is indicating it's working and doing something. And by no means do you have to stay in this particular screen. If you were wanting to perform another task, you could go out of the screen here and then come back in, and you could see it is actually discovered, right, within the pane here of the discovery, right? So you can see here that we've created the first 2U Ampere server, and what we're going to do is double click on it, and it's going to bring up a new pane or new window to associate this 2U Ampere server to the 2U rack that we want to associate with. So the first thing is our group name. Where do we want these to be associated with? If you noticed and click on here, we don't see that rack that's associated with that Ampere farm, right? Because we haven't chose the pod of Ampere farm. So all of them by default get looped into this default group name of rack location. So you don't have to define a pod, right? Say maybe if you had several racks and you had just one rack and you wanted to take all of those 2U Ampere servers and combine them into one rack, and you didn't want to create a pod of Ampere farms, you can do so, right? You're not constrained to having to always create a group or a pod. But logically speaking, you probably want to associate applications or physical servers and keep them contained and into one rack, right? You don't want to mix Ampere servers and AMD, right? You can do so, but you maybe want to have some organization within your data center to define this, right? So we want to click on this Ampere type farm. And so we're going to come down to where it says Ampere farm. And you can notice here we provide color coding for each particular pod. And we're going to click on Ampere farm. And the next thing we're going to do is it opens up the two racks associated now that we previously did and in the previous podcast where we created those racks and associated them with the pods. We're going to choose basically what we call the 6F1 Phoenix data center itself. And then we're going to do the drawer location, right, itself. So we're going to choose in slot location number 1, and then we're going to save it, right? And then we're going to do this for the second particular one, right? So let's now see if we associate that server in that particular floor. And you can see here that we have the 2 Ampere servers, 2U Ampere server, and we're starting in slot unit number 1. If we click on here, we can see here some information such as the BMC IP address, the MAC address, the serial number, the drawer height, which is a 2U form factor, and very descriptive information about this server. So we see a check mark now, and it's associated, it's in good health, associated with this rack location for 2U. Okay? So the next one we're going to do is we're going to add the second one of our 2U server into rack location 2U rack, where we have the first one, which is defined in rack slot unit 1. So the next one we're going to plug in here is 172.24. Let's see here, 172.24, 199.121. And again, you can provide the front, or what we call the starting range, and also the back range, the back end range, to provide you contiguous space. But in our case, it's going to be one device or one 2U Ampere server we're going to discover. So we're going to plug in 121 there, and then we're going to submit again. And then again, it's going to basically push this task to the back end and perform a what we call device discovery. And while we're doing that, you'll see here that it's, again, the cloud icon, and then it automatically discovers it because we see discover number 1 here. So it discovered 1. If you were discovering a range, they would all show up on the side card here, indicating numerically sequenced how they were able to discover them within the rack. So the next thing we're going to do is click on it here again. And this is now an ARS-520M-NRL device we had discovered. We're going to choose the Ampere farm group. And the location now is going to be in position floor number 1 again. And then now you noticed 1 is now not available to us because the previous server occupies that slot. And because it's a 2U form factor, it occupies 2 slots. So 1 and 2 are no longer variable options to choose, right? So we're going to put it into the next available slot within the rack, which is rack slot unit 3, and then click save here, and then it'll automatically submit that to the back end. And then we'll go out and perform device discovery of that device, getting all the important attributes through a Redfish endpoint query. And you can see here that it's now been added. The second server's been added into the 2U form factor rack. So we're going to add a third one into the 2U rack. And by clicking on device discovery again, plugging in our IP address of 172.24.199.42. And again, we're going to use the ending location of 42 and submit, and it will submit it to the back end and perform device discovery. So our agent will go out, collect metadata as a source of truth, being the open BMC of the Ampere server, pull all that Redfish endpoint data in, package it up into a unified dashboard within SuperCloud Composer. So we're going to be now discovering the ARS 210ME-FNR, and we're going to double click on that one. And then again, we're going to change the group to Ampere Farm as the pod. And then we're going to choose 6F1 Phoenix Data Center. And now we're going to start at position rack slot unit 5, and then basically save it. So once we save it, at this point, all of those slots now, which are rack slot unit 1, rack slot unit 3, and rack slot unit 5 have now been occupied within that rack. So let's look at it at more high level detail. If we click on there, you can see here that each of these servers have been populated in rack slot unit 1, rack slot unit 3, and rack slot unit 5. So you can see here the blue circle indicates the starting position, and because it's a TU form factor, it occupies 2 slots within that particular rack. Now, let's say you were performing device discovery and somehow you didn't discover the device. How would you go in and determine through logs whether it was successfully done or not? And that's easily done by coming here to the log information. And log information here, we can click on for tasks. And you can see here, based on what we've done, is we performed 3 tasks of discovery. And you can see each of these tasks have been completed with a starting point and an ending point timestamp. And by clicking here for more, you can see descriptive detail of providing the range that was provided to the back end. It started its device discovery. It started pinging that particular IP address, processing and pulling all the BMC attributes through a Redfish call endpoint. Our agent has pulled that metadata from the BMC of the open BMC, and then was able to successfully identify and discover that particular server. And that server then was registered within the drawer configuration within PodView. So each of these servers now, these 3 servers, which are Ampere servers of 2U, are now a device that can be monitored, managed, and alerted through SuperCloud Composer. So we'll go in and look at more detailed information about looking at components that are inside this server, looking at our signature lifecycle management for servers within SuperCloud Composer next time. Thanks for joining, and I wish you a great day. We'll see you next time.